So these are the additional notes for combinations. Again, the key thing in combinations is that the order doesn't matter. And you're going to get permutations and combinations questions mixed together, so you need to be able to see, does the order matter or not? And we saw already that all a combination is a permutation with the order divided out. So it's the same formula as the permutation formula, but we add an extra r factorial on the bottom because we're getting rid of that order. We saw this other notation that textbooks sometimes use. Some special cases, if you have n items and the order doesn't matter and you choose all of them, there's only one way to do that. Or if you have n items and you choose one of them, there is n ways to do that, right? You have to pick a book for English class. There's 8 choices. You have to choose one. How many different ways can you do that? 8 choose 1 would just be 8 ways to do that. You could pick any one of those books, right? Right? If you have 3 books and you have to read all 3 of them, there's only one way to do that. You have to choose all 3 of them. We also saw, and these numbers are the same numbers that we saw in that question that had 4 applicants to work at a canteen or something, and then it would be 10 choose 4, and then they said, oh, now we need 6 applicants, and they did 10 choose 6, and we noticed that these are the same. So you could get questions with a little bit of algebra. Let's say I have 17 choose x plus 1 is equal to 17 choose x plus 4.
Excuse the interruption. If your vehicle has a license plate DBC 327 and bomber plate B11386, please go move your vehicle. DBC 327 and bomber plate B11386. Thank you.
If they're equal, those 2 numbers there will add up to the number out in front. So if you got a question like this, you would know that 17 would equal x plus 1 plus x plus 4. And solving to this, you would get x is equal to 6. And then we check, this would be 17 choose 7, this would be 17 choose 10. Does it make sense that 17 choose 7 is equal to 17 choose 10? Absolutely. Find the number of 5-card poker hands. So a common game that people play with cards is poker. And in poker, you have 5 cards that are yours. So if we look at how many poker hands are possible, first of all, does the order matter that how they deal you the cards? No, you get your cards, you can mix them around however you want. So we know that the order doesn't matter, and this becomes 52 choose 5. If we put that into our calculator, almost 2.6 million different poker hands. So maybe this is part of the fun of that game, is that there's so many options of what you could get. And so it doesn't get boring because each hand is somewhat different than what you've had before. So we're going to look a little bit about this because sometimes figuring out the probabilities in games like this are very interesting. Committee. So first of all, we see the word committee, we see the word group. The order order doesn't matter. Committee of 2 boys and 3 girls is to be selected from a class of 15 boys and 18 girls. How many ways can this be done? Well, you have 2 decisions to make here. You have to decide which are going to be your boys and which are going to be your girls. So we'll see that sometimes some of the techniques that we learned earlier to solve permutation questions also come up in combination questions. Now, since the order doesn't matter, it'll be 15 choose 2 for the boys, and 18 choose 3 for the girls, and with decisions, we would always multiply in between. Now, sometimes on a multiple choice question, they could have this on non-calculator, and on non-calculator, they would write their answer like this. Seeing if you know how to use the formula. Remember combinations? If you have 15 choose 2, there'd be a 2 factorial on the bottom, but the bottom number would also have a 13 factorial because they add up to the top one. Multiplied by 18 factorial over 3 factorial, 15 factorial. And what would most likely be the answer in a multiple choice? If it was non-calculated, they would probably simplify these 15 factorials. And they might have this as the final answer. Yes? Oh, and that would still be there. Thank you. A group. A group of students can be separated into 3 smaller groups. Group A, 8 students. Group B, 5 students. Group C, 7 students. Okay? If you're doing group work in a class, it doesn't matter the order that they put you in the group. So this is a combinations question. And we have 3 decisions to make. We have to decide who is in group A, who is in group B, and who is in group C. Now, group A has 8 students. Does it make sense that you start off with 20? We'd have to choose 8 of them to be into group A. Then, right? So the teacher, there's 20 of you in class. I go, okay, you guys are in group A. And the rest that are waiting there, now I need to make group B. You see that there's only 12 students left. And now I have to choose 5 to be in group B. So I choose my 5 to be in group B. And there's going to be 7 students left. I'm hoping at this moment they realize they're going to be in group C. Right? It's like group A is made, group B is made. I shouldn't have to say the rest of you are in group C, but we could show, even though there's 7 left, choose 7, there's going to be only one way to do that. Everybody who's left is going to be in group C. And of course, since these are decisions, we would multiply all of these together. And if we would expand this, and if we would do this again, and choose the order different. Start with 20, choose the 7 for C first, and then there's 13 kids left, choose 8 for A, and then 5, choose 5. You'll get the same answer, guaranteed. It doesn't matter which group you choose first. The numbers look different, but if we wrote these out with the formulas and canceled things out, they would all cancel out perfectly to look like this. But we won't show that because we have not enough time. But poker hands again. If I deal you 5 cards, you might get a club in the 5 cards that I give you, or you might not. What we want to do is we want to count how many different ways could I give you 5 cards that there are no clubs in there at all. So sometimes with counting, we think, well, if I have my 52 cards here, how could I guarantee that you don't get a club when I give you 5? I just take the clubs out. Now when I give you 5 cards, will you get a club? No. That's a pretty good strategy. Now, if I take the clubs out and there's 39 left, now every group of 5 made from that will not have clubs, and every group will be different. So we're really wondering how many groups of 5 can we make from 39 cards, and that will count all the poker hands without clubs. This is a really pretty number. Let's look at it. Isn't that a pretty number? I think that's it. If there was a numbers fashion magazine, I think that number would be. Why do we have 39 choose 5? Because we're making a poker hand which has 5 cards. So we need to make a group of 5 from 39. And then this last question, I am going to provide you with 3 solutions. But they might all be wrong. They might all be right. Or maybe 1 is right and 2 are wrong, or 2 are right and 1 is wrong. But my job is I've been hired as a salesperson to sell all 3 of them as true. And they might all 3 be true. You have to decide, is there anything wrong with what I'm trying to sell you? Because your brain will try to sell you ideas on the test. And your other brain, I don't know, you have 2 halves, right? One brain tries to tell you this is what you should do. Your other brain should say, wait a minute, you might be doing something wrong here. So, here are the 3 right ways to do this question. Okay? Find the number of poker hands with at least 3 clubs. Well, since I already have my clubs taken out, there's 13 of them, and I want at least 1 club, I go to those 13 cards and I choose 1. Then I have at least 1 club. Then I take the other 12 cards, I put them back into my deck, shuffle it up, and I choose 4 more cards. I could get more clubs, or I could just have the 1, but I'm guaranteed to have at least 1. So now, I have 51 left, I choose 4 more, and I guarantee myself to have at least 1 club, but I might have more. That's solution number 1. Solution number 2. Well, I just counted how many poker hands had no clubs, so why don't I use the not strategy? The not strategy says, if you count all of them, so 52 choose 5 is all the poker hands, and then we subtract the bad ones, and we had 39 choose 5 with no clubs, everything you would have left would have at least 1 club. This is solution 2. Solution 3, I'm going to count things with cases. I'm going to separate things and say, first case, case 1, 1 club. So if I count 13 choose one, because there's 13 clubs, I choose one. And from the other 39 cards, I choose 4 other ones. That would count how many ways I have exactly one club. This solution is longer, but it works perfectly fine. Case 2, we do 2 clubs. Well, now we take our 13 clubs, we choose 2 of them, and then of our 39 cards left, we choose 3. And I hope you can see that then we'll have case 3, have 3 clubs, 13 choose 3, 39 choose 2. Case 4 would have 4 clubs, 39 choose 4, oops, 13 choose 4, 39 choose 1, and then finally case 5, we have our hand with all 5 clubs, which is just 13 choose 5. Since this is cases, I would add them all up, and I would get a total, and this would work out perfectly as well. So here are 3 solutions to this question, and I've sold them that all 3 make total sense. Now, have I created trust issues during here? Do you believe me that none of them work? Or have I done really good, and you're like, yeah, you're a good teacher, Mr. J. I agree, all of them are right. Or did I play a trick on you? And some of them are right, and some of them are wrong. What would you do to check? Yeah, we'll see if they're all the same answer. Okay, so let's do that quickly. Here's the answer for the first one. Oh, but maybe before we do that, we should let's see what your gut feels. Okay? Before we say anything out loud, which one was your favorite of the 3 solutions? 1, 2, or 3? And then which one is your least favorite that you think is most likely, if there's one that's going to be wrong, which one is your least favorite? So, I want you to pick a favorite one, and then a least favorite before we get to any questions.
I have a question about number 2.
Yeah.
So, are all of these under the impression that, like, you're looking at the cards, like, you know what the cards are?
Well, when you count, like when we're counting,
Yeah.
the 52 choose 5 just picks 5 cards of 52.
Yeah.
Okay? And you're counting all the different groups. The 39, you've taken out the clubs. And the ones that are left, now you're choosing 5 from the ones that are left. You can look at them or not. It doesn't matter for counting.
So the first one has the clubs in it.
Yeah, 13 choose 1. I make sure that I choose 1 club.
So, like, the second one, so you're looking at all the clubs.
All the clubs, I choose 1, and whatever's left in the clubs gets thrown back in, mixed up, and you choose 4 more.
Okay.
So you could get more clubs. You don't have to. Okay? So, we'll go with favorites first. Who had number 1 as their favorite? Who had number 2 as their favorite? Who had number 3 as their favorite? Okay? Least favorite. Who had number 1 as their least favorite? Number 2 is their least favorite. Number 3 is their least favorite. Okay? So, now we're going to get the numbers here. Okay. Well, the numbers aren't all the same. So that means they can't all be right. We still have the possibility that all of them are wrong. We still have the possibility that 1 is wrong and 2 are right, or 2 are wrong and 1's right. Is there a way to tell that one of these has to be wrong. Leo.
I'm pretty sure number one is larger than the total amount of 5-carded hands you can make.
Right, I don't know, that might be close, might not be quite right, I'm trying to do it from memory. It's good, okay? That's the total number of hands. You can't have more with a restriction than the total. That's impossible. If there's only 2.6 million poker hands, and then all of a sudden, oh, and by the way, 3.2 of them, 3.2 million of those 2.6 million have one club. Like, what? That doesn't make sense, logically. Well, that's saying that this method is wrong. But it sounds so good. So we're going to talk about why this method is wrong in a bit. These two both work. I like the middle one as far as, like, the cases works, but it takes forever. So it's just a little bit annoying. The not strategy is way faster. And you'll find that when you get questions with this, at least, it's often hinting that you should use a not strategy. Okay, so, why is this one wrong, and what is the common mistake that happens in here? I'll show it first with an example. One of the hands I could have picked is, with the 13 choose 1, I could have got my 2 of clubs. Right? That's a possibility. Then in my 51 choose 4, I picked 4 more cards. I might have had a 7 of hearts, a 3 of diamonds, an 8 of clubs, and the king of spades. Right? That's a possibility that I could get there. So here's my 1 club, and then here's my 4 other cards. Next, I do it again. 13 choose 1, I pick the 8 of clubs. Then, I go to the other 51 choose 4, and I happen to get the 7 of hearts, the 3 of diamonds, the king of spades. Does anyone see the problem that could happen? I could get the 2 of clubs here. And these are the same. I've counted something more than once. And that caused a problem. How much did I overcount? Only by 1.2 million. Not too bad, right? Where could this be a major problem? You're working as a cashier. Someone buys a candy bar, they give you $20. You give them change, but in giving them back the change, you're off by $1.2 million. Will you get fired from your business? First of all, why does your cashier have $1.2 million in it? That would be another question that I would have. Okay, so being off by 1.2 million is a lot, but our idea was not far off. I convinced you that this was a good strategy. The problem is that if you are using decisions with combinations, there can be no overlap. And here I'm picking clubs, and here I have a chance to pick clubs again, which creates a mini order, right? I could pick the 2, then the 8 is different than the 8, then the 2. And I create mini order inside of it. So in these ones with decisions, you have to make sure there's no overlap in your groups. So in the cases, here is clubs. Here there was no clubs. So we have no overlap, and that's why that strategy worked, and the first strategy did not. So I have for you extra, just like the extra booklet, permutation questions. Combinations isn't as big as permutations. So here are extra practice